In the lesson video, we talked about radians. We talked about what they were, what made them more natural. So let's go over a little bit of that now. A radian is another way to measure angles. A circle has 360 degrees and 2 pi radians. So 2 pi radians is the same thing as 360 degrees. They're just two different ways of thinking about it, but the same angle. A triangle has 180 degrees and pi radians. And we talked about how the radian was a relationship between the arc length and the radius of a circle. Let's do some examples now. Find the side L. Now, this is pretty easy once you know the formula for radians. Using radians, our arc length L is equal to angle in radians, this is very important, it must be in radians, times radius. So that's pi over 4 times 5. So our arc length L is equal to 5 pi over 4. What's pi over 4 radians in degrees? Pi over 4 radians in degrees. If we multiply 2 pi by 1 over 8, we get pi over 4. And 2 pi radians is equal to 360 degrees. So if 2 pi over 8 is pi over 4, then 360 over 8 is also equal to pi over 4 radians. And that's 90 over 2, or 45 degrees. Let's try another example. Here's our problem. Given that our arc length is length 10, and our angle is pi over 3, find the radius r. Let's use our formula. We know that arc length is equal to angle in radians times the radius. So that's 10 is equal to pi over 3 times r. And if we arrange this, we get 30 over pi is equal to r. Just a little bit of algebra once we know radians. Let's try a similar problem. Here's our new circle. Given that our arc length is 16 and our radius is 8, find the angle here, or as it might be described in the problem, find the angle subtended by the arc. So, by our formula, we know that arc length is equal to angle in radians times the radius. So 16 is equal to the angle we want to find times 8. So we divide by 8 both sides, we get 2 is the angle we want to find. This angle is equal to 2 radians. Now you'll usually see radians in terms of pi, but not always. There's a similar formula for area. Now, if we were using degrees, an angle in degrees, and we wanted to find an area of this sector, we would have to find pi r squared, that's the area of the whole sector, this whole circle, and then multiply it by our angle in degrees over 360. For radians, the same thing is just half r squared times the angle in radians. A little less messy. Let's try to apply this now. Say this angle is 2 pi over 3 radians, and the radius is 500. What is the area of this region? By our formula, area is half r squared, so that would be 500 squared times the angle in radians. That's 2 pi over 3. We do a little bit of cancelling. 25, 0, 0, 0, 0 times pi over 3. And that's your total area. So you have two formulas. To revise, we have two formulas that we use with radians. The area of a circle is equal to half r squared times the angle in radians, and an arc length L is equal to the radius times the angle in radians. And of course, you should know how to transfer back and forth between radians and degrees. 2 pi radian is equal to 360 degrees, or if this is easier to remember, an angle in degrees is equal to 180 over pi times an angle in radians. Two different ways to express it.